Hello friends, I'm back with a new video on Arithmetico geometric series. In this video, I'll be talking about what is an arithmetico geometric series and how to find the sum of such a series. So let's begin. Suppose I'm given with an AP. Let's write a general AP. A plus D, A plus 2D, and A plus n minus 1, D. Okay, and suppose we are also provided with a GP B, BR square, BR cube up to BR to the power n minus 1. So obviously A is the first term, D is the common difference of the AP, and regarding GP, B is the first term, and I made a mistake here. Okay, no problem. So this is BR square, BR cube, and so on. Fine. So R is the common ratio of this GP. Okay. Now we will define a new series by multiplying the corresponding terms of this AP and this GP, which we call AGP, arithmetico geometric progression, which is a combination of the arithmetic progression and the geometric progression. Okay. So when we multiply A with B, we get AB. When we multiply the second terms, we get A plus D into BR. Third term will be A plus 2D BR square, and the last term will be A plus n minus 1D BR to the power n minus 1. Okay. So this is how an arithmetico geometric progression is formed. Okay, each term of the AGP is composed of two elements. One is derived from the AP and another is derived from the GP. Okay, let's see how to find the sum of an AGP. Okay, so let us denote the sum by Sn. Fine. What will be Sn? Sn will be AB plus A plus D BR plus A plus 2D BR square to A plus n minus 1D multiplied by BR to the power n minus 1. Okay, what we do, we find RSN. What is R? R is the common ratio of the given GP. Okay, so we write it as ABR plus, I have shifted one term. Okay, I have shifted one term deliberately. I have left this place blank due to some reason. Okay, this is ABR, and again A plus D BR square plus, and the last term will be A plus n minus 1 D into BR to the power n. Okay, now I will subtract the second series from the first one. Here I will get Sn minus RSN is equal to, write down AB as it is, subtract this one, we get ABR will be cancelled, we will be left with DBR. Here ABR square will be cancelled, ABR square will be cancelled, and 2 DBR square minus DBR square, we will be left with DBR square. Again, from the pattern, I can say the next term will be DBR cubed. Here we will get DBR to the power n minus 1, and this last term will be written as it is, minus A plus n minus 1 D BR to the power n. Fine. This is 1 minus R into Sn is equal to AB plus DBR can be taken common from this part of the series. Okay, so we take DBR common. What's left is 1 plus R square plus R cube, 1 R square R cube up to R to the power n minus 2. Okay, minus A plus n minus 1 D BR to the power n. Fine. So 1 minus R Sn becomes AB plus DBR. This is a GP with the common ratio R and number of terms equal to n minus 1. So the sum can be written as 1 minus R to the power n minus 1 upon 1 minus R minus a plus n minus 1 d br to the power n. Fine. So Sn becomes ab upon 1 minus r plus dbr 1 minus r to the power n minus 1 upon 1 minus r whole squared minus a plus n minus 1 d br to the power n upon 1 minus r. Okay, so this is the formula for sum of an AGP. This looks a little bit tedious, but the good news is you are not required to remember this formula. Only you are required to know the method, because while actually solving the problems on AGP, we are not supposed to remember this formula. We simply go through this method. Okay, we write the sum, then we multiply by the common ratio, and then subtract both the series to obtain this. So actually, while doing the questions, I am going through all the steps that I have done in the above process. Okay, so we are not required to, actually we are not supposed to remember this formula, but as I was supposed to show this to you, so I just did this. Now there is one more thing regarding this. Suppose the number of terms tends to infinity and the common ratio lies between minus 1 and 1. Okay, if this is the case, then I can say Sn is equal to ab upon 1 minus r plus dbr upon 1 minus r squared. Okay, so this is the relation if number of terms tends to infinity and the common ratio is less than 1. Okay, how? As r is less than 1, r to the power n and r to the power n minus 1 will tend towards 0. Okay, so here we have r to the power n, this term becomes 0, and this term again becomes 0. Then I am left with dbr upon 1 minus r square. Okay, so this is the sum when these conditions are provided. Okay.